सर सुधीर सुधीर सर
आसिफ सर
సుధీర్ సార్ ఇంకా ఆసిఫ్ సార్ ఇంకా ఆడియో కనెక్ట్ చేసుకోలేదు సార్.
Sir, Sudhir sir, Sudhir sir,
Sudhir sir,
Hello, sir. Is there class?
Sudhir sir, Sudhir sir. Hello,
Sir, Asif sir watching, sir.
hello,
Yes, sir.
hello.
షేర్ అవుతుందన్నా షేర్ అవుతుందా ఆమె ఆడిబుల్ బేటా
ఆడిబుల్ సార్ అవుతుంది.
ఎందుకు ఇది స్టక్ అయిపోతుంది నాకు అర్థం కాలే వినిపిస్తుందా
అనిపిస్తుంది సార్.
చలో కీప్ ది నెక్స్ట్ చాప్టర్ బేటా magnetism and matter. Magnetism and matter. Magnetism and matter.
చాప్టర్ అయిపోయిందా సార్?
ఏదన్నా
ప్రెజెంట్ కెపాసిటెన్స్
అయిపోయిందన్న.
ఓకే.
చలో keep the next heading beta magnetism and matter. This is 25/11/2020. Chalo. So in this one first let us try to talk about bar magnet. Bar magnet. What do you mean by a bar magnet? Bar magnet is nothing but beta it is a rod shaped metal object. It is a rod shaped metal object which produces
సార్ కెపాసిటర్స్ లో ఛార్జింగ్ అండ్ డిశ్చార్జింగ్ కెపాసిటర్ ఇంకా
అది లేదు నాన్న ఇది అది EMI లా ఉంటుంది. ఓకేనా?
యా ఓకే సార్. అంటే కెపాసిటర్ అంతేనా సార్ ఇంకా లాస్ట్?
అంతే ఛార్జింగ్ డిశ్చార్జింగ్ మనం మ్యాగ్నెటిజం లో చేసుకుంటాం.
యా ఓకే సార్. సార్ నోడల్ అనాలిసిస్
మనకు సిలబస్ లో లేదు, అది ఎక్స్ట్రా సిలబస్ అది.
సార్ ఇప్పుడు కాంపిటేటివ్ ఎగ్జామ్ అన్ని ఉన్నాయి కదా సార్, సిలబస్ మొత్తం ఉంది సార్. కాంపిటేటివ్ చూసుకుంటే మొత్తంగా సార్ సిలబస్
దేంట్లోరా
అంటే మెయిన్స్ అవన్నిటికి సార్ సిలబస్ మొత్తం కదా సార్.
ఏ టాపిక్ రా
సార్? నోడ్ అనాలిసిస్.
నోడ్ అనాలిసిస్ అనేది ఏమీ లేదు, అది హౌ టు క్యాలిక్యులేట్ ఎఫెక్టివ్ రెసిస్టెన్స్. మీకు ఎఫెక్టివ్ రెసిస్టెన్స్ క్యాలిక్యులేట్ చేయడానికి నేను ఎన్ నెంబర్స్ చెప్పాను కదా, అది నోడల్ అనాలిసిస్ అనేది ఇంజనీరింగ్ లో వస్తుంది, మనకు జేఈ మెయిన్స్ లో అడ్వాన్స్ ఎక్కడ రాదు అది.
దాని మీద ప్రాబ్లమ్స్ కూడా ఉన్నాయి సార్ బుక్ లో, అందుకే.
అవును, ఆ ప్రాబ్లం నోడల్ అనాలిసిస్ కాకుండా మీరు జనరల్ మెథడ్ లో చేయండి.
ఓకే సార్.
సిరీస్ కాంబినేషన్ లో చేయండి, లేకపోతే సిమెట్రీ మెథడ్ యూజ్ చేసి చేయండి. ఓకేనా? Come to next topic beta magnetism and matter. In that one we are talking about a bar magnet. What do you mean by bar magnet? It is nothing but a rod shaped metal object which produces magnetic field beta, which produces your magnetic field, which produces a magnetic field in its surroundings, okay. So it is a rod shaped metal object which produces the magnetic field in its surrounding. At the two ends of it there are two magnetic poles beta. At the two ends of it there are two magnetic poles. One is known as north pole and another one is known as of your south pole. Okay, so what is a bar magnet beta? It is a rod shaped metal object which produces the magnetic field in its surrounding part of a relation, and at the two ends of it there are two magnetic poles beta. Okatemo north pole, inkotemo south pole part of a relation. And whenever a bar magnet is suspended beta with the help of a thread, magnet will rest always along your north south direction. So write this point also. When suspended freely with the help of a thread, a magnet always A magnet always rests in north-south direction. North-south direction. అంటే ఒక బార్ మ్యాగ్నెట్ ని ఒక థ్రెడ్ తీసుకొని సస్పెండ్ చేశాను అనుకోండి ఇట్లా. ఇది థ్రెడ్ and here is your bar magnet. ఇదో బార్ మ్యాగ్నెట్. ఓకే, సో దీన్ని థ్రెడ్ తో ఇట్లా కట్టేశాను ఇక్కడ. ఓకే, it has a two poles, but I told you what are the two poles. This one is of your north and this one is of your south. Okay, so it in the equilibrium, it always comes into the play. ఇది వచ్చేసి నార్త్ పోల్, ఇది వచ్చేసి సౌత్ పోల్, ఇది వచ్చేసి ఈస్ట్, ఇది వచ్చేసి వెస్ట్. ఓకేనా? సో whenever when we suspended freely from the help of a thread, a magnet always rests in which direction? With the north and as well as of your south direction. North and south direction. That means the pole pointing the north is a north pole and the one pointing towards the south is nothing but of your south pole. You can write here the pole pointing towards north, is north pole. And the one pointing towards south is called south pole. Is called what? South pole. Okay, so the pole which is pointing towards the north is called north pole and the pole which is pointing towards the south is called as of your south pole. So what is a bar magnet, beta? Bar magnet is a rod shaped metal object which produces the magnetic field in its surrounding part of a relation. And at the two ends of it there are two magnetic poles. One is known as of your north pole, another is known as of your south pole. And whenever we suspend a freely suspended bar magnet, a bar magnet will always comes into the which direction, beta? North to south direction lo vastundi. Chudandi, north pole of the bar magnet is towards the north and the south pole of the bar magnet is towards the south part of a relation. Is that clear for everyone? Okay na? Chalo. The pole pointing towards the north is known as north pole and the pole pointing towards the south is called as of what? South pole part of relation. So that is about your bar magnet. Now if I'm going for the properties, beta, properties of bar magnet, properties of your bar magnet, properties of your bar magnet. School is advanced మీరు. So what are the basic property, beta? Like poles will repel, unlike poles will attract. The first one is your like poles repel each other. Like poles repel each other and unlike poles attract each other. So confirmed test of the polarity is repulsion and not attraction, beta. If I need to confirm, so I can say that confirmed test of polarity, or we can say magnetism, is repulsion. But not attraction. Okay na? ఒకవేళ మన magnetism property confirm చేయాలంటే we should be depending upon the property of your repulsion but not on your attraction. So what is the first property of a bar magnet, beta? Like poles will repel each other and unlike poles will attract each other right now. So that is the first point you need to remember in the properties of your bar magnet. The next one is of your magnetic monopoles. magnetic monopoles do not exist. Do not exist అంటే ఓన్లీ నార్త్ పోల్ రావడము ఓన్లీ సౌత్ పోల్ రావడము అలాంటిది జరగదు మనకు. లైక్ సే ఫర్ ఎగ్జాంపుల్ మన దగ్గర బార్ మ్యాగ్నెట్ ఇట్లా ఉంది అనుకుందాం, ఓకేనా, అండ్ వీఆర్ హ్యావింగ్ ద పొలారిటీస్ ఆఫ్ దిస్ వన్. లైక్ సే ఇది ఒక నార్త్ పోల్, ఇది ఒకటి సౌత్ పోల్. నువ్వు దీన్ని సెంటర్ నుంచి కట్ చేసావు అనుకో రైట్ నౌ, ఇఫ్ యూ హావ్ కటెడ్ దిస్ వన్ ఫ్రమ్ ద సెంటర్, సో వెన్ యూ కట్ ఫ్రమ్ ద సెంటర్ దిస్ విల్ బికమ్ వన్ పీస్ అండ్ దిస్ విల్ బికమ్ ఫర్ మీ అనదర్ పీస్. అవునా కదా? సో అనదర్ పీస్ లో what is happening right now, previously it was north pole kada, it will get here south pole. Previously it was south pole kada, here it will get of a north pole, and opposite polarity will exist. So on breaking, this one is your on breaking, isn't it? So when you break it perpendicularly right now, or when you break it horizontally or vertically, నార్త్ పోల్ ఉంటే దాని యొక్క ఆపోజిట్ పొలారిటీ వచ్చేస్తుంటది దానికి బేసికల్. ఇస్ ఇట్ క్లియర్ ఫర్ ఎవ్రీవన్? అంటే మ్యాగ్నెటిక్ మోనోపోల్స్ డు నాట్ ఎగ్జిస్ట్. మోనోపోల్స్ అనేది మనకు డు నాట్ ఎగ్జిస్ట్ ఇన్ ద బార్ మ్యాగ్నెటిజం. ఇస్ ఇట్ క్లియర్? చలో, పాయింట్ నెంబర్ 3. The poles are situated.
సార్ మోనోపోల్స్ అంటే బార్ మ్యాగ్నెట్ డివైడ్ చేయడమా సార్? 2 పార్ట్స్?
లేదు నాన్న, అంటే ఒక పోల్, మోనో అంటే సింగిల్ కదా, మోనోటామిక్ డయాటామిక్ అంటే ఓన్లీ నార్త్ పోల్ ఓన్లీ సౌత్ పోల్ అనేది మ్యాగ్నెట్ ఎగ్జిస్ట్ అవ్వదు.
ఓకే సార్, అవును.
అవునా కదా? ఈ బార్ మ్యాగ్నెట్ ఒకవేళ నువ్వు కట్ చేసావు అనుకో, దీని టైనీ పార్టికల్స్ లో చేసినా కూడా మోనోపోల్ ఎగ్జిస్ట్ అవ్వదు. నార్త్ పోల్ కి ఇమీడియట్ గా సౌత్ పోల్ వచ్చేస్తుంది, అదే విధంగా సౌత్ పోల్ అంటే ఇమీడియట్ గా నార్త్ పోల్ వచ్చేస్తుంది. నువ్వు దీన్ని 1,000,000 పార్ట్స్ లో కట్ చేసినా కూడా ఎవ్రీ పార్ట్ విల్ హ్యావ్ అగైన్ నార్త్ అండ్ సౌత్.
ఓకే సార్.
ఓకేనా? చలో, థర్డ్ పాయింట్ చూడండి. The poles are situated near the ends of the magnet. Near the ends of the magnet and not exactly at
హలో
ends.
సార్.
Yes beta.
సార్ అది వర్టికల్ గా కట్ చేస్తే ఏమవుతుంది సార్?
వర్టికల్ గా కట్ చేసినా కూడా అంతేనా? చూపిస్తాను చూడు.
పోల్స్ చేంజ్ అవ్వవా సార్?
పోల్స్ ఎప్పుడు చేంజ్ అవ్వవు. ఇప్పుడు చూడు, ఇది బార్ మ్యాగ్నెట్, ఇది నార్త్ పోల్ అనుకో, ఇది సౌత్ పోల్. ఇప్పుడు నువ్వు వర్టికల్ ఇట్లా కట్ చేసావు అనుకో రైట్ నౌ, నీకేమైపోయి వస్తుంది, మళ్ళీ నీకు ఈ పీస్ ఇట్లా వచ్చేస్తుంది, మళ్ళీ నీకు ఈ పీస్ ఇట్లా వస్తుంది. నీకు యాజ్ ఇట్ ఈస్ గా నార్త్ ఉంటుంది, ఇది యాజ్ ఇట్ ఈస్ గా సౌత్ ఉంటుంది, ఇది యాజ్ ఇట్ ఈస్ గా నార్త్ ఉంటుంది, ఇది యాజ్ ఇట్ ఈస్ గా సౌత్ ఉంటుంది. ఓన్లీ పవర్ తగ్గుతూ పోతుంటది అంతే.
ఓకే సార్.
ఓకేనా? ఓన్లీ హారిజాంటల్ గా కట్ చేసినప్పుడు దానికి పొలారిటీ వచ్చేస్తుంది. ఓకేనా? సో ద పోల్స్ ఆర్ సిచువేటెడ్ నియర్ ద ఎండ్స్ ఆఫ్ ది మ్యాగ్నెట్ బెటా అండ్ నాట్ ఎగ్జాక్ట్లీ ఎట్ ద ఎండ్స్.
సార్
చెప్తున్నాను.
అది బ్రోక్ అయ్యాక మళ్ళీ అట్రాక్ట్ కావు కదా సార్?
ఎవరన్నారా మ్యాగ్నెట్స్ బ్రేక్ అయితే అట్రాక్ట్ అవ్వవని? ఎక్కడైనా చదివావా? స్కూల్లో చదివలేదా ఎప్పుడైనా? ఒక బార్ మ్యాగ్నెట్ ని నువ్వు కట్ చేయి 2 పీసెస్ లా, ఎవరన్నారా కట్ అవ్వదని, అట్రాక్ట్ అవ్వదని ఎవరన్నారు? You can cut this bar magnet into your infinite pieces బెటా, నీ దగ్గర కెపాసిటీ ఉంటే. అండ్ ద మూమెంట్ యూ కట్ ఇట్, దానికి ఆపోజిట్ పొలారిటీ అయిపోయి అది బార్ మ్యాగ్నెట్ లా మళ్ళీ యాక్ట్ అవ్వడం స్టార్ట్ అవుతుంది. కాకపోతే పవర్ తగ్గుకుంటా పోతుంది. ఒకవేళ దీని దగ్గర 100% ఉంది అనుకో, దీనికి 50 అవుతుంది. ఇంకా తగ్గావు అనుకో మళ్ళీ దానికి 25 అవుతుంది. ఇంకా తగ్గావు అనుకో 12.5, అట్లా పవర్ తగ్గుతూ పోతుంటది. కానీ బట్ ఇట్ విల్ బి యాక్టింగ్ యాజ్ ఆఫ్ యువర్ బార్ మ్యాగ్నెట్. ఓకేనా? ఇస్ ఇట్ క్లియర్? చెప్పండి.
నార్త్ సౌత్ ఎందుకుంటా సార్? ఈస్ట్ వెస్ట్ లో రిపల్షన్ అట్రాక్షన్ ఉండదా సార్?
ఉండదు నాన్న, అది ఎక్స్పెరిమెంటల్ కండిషన్ అది.
ఓకే సార్.
మన ఎర్త్ కూడా ఒక మ్యాగ్నెటే కదా.
ఎస్ సార్.
ఎర్త్ లో కూడా మనకు ఎన్ నెంబర్ ఆఫ్ మ్యాగ్నెటిక్ లైన్స్ ఆఫ్ ఫీల్డ్స్ ఉంటాయి. అది మన ఎర్త్ చుట్టూ కూడా మ్యాగ్నెటిక్ ఫీల్డ్స్ ఉంటాయి. ఆ మ్యాగ్నెటిక్ ఫీల్డ్ అనేది ఎప్పుడు నీకు సౌత్ నార్త్ డైరెక్షన్ ఉండడం వల్ల నువ్వు ఏ బార్ మ్యాగ్నెట్ ఆన్ ద సర్ఫేస్ ఆఫ్ ఎర్త్ పెట్టినా కూడా అదే డైరెక్షన్ లో అలైన్ అవుతుంది అని అర్థం. ఎర్త్ ఉంది కదా, ఎర్త్ కి బేసికల్ గా వెన్ యూర్ టేకింగ్ ద ఎర్త్ కండిషన్, ఇట్లా ఎర్త్ కి నెంబర్ ఆఫ్ మ్యాగ్నెటిక్ లైన్స్ ఆఫ్ ది ఫోర్సెస్ ఉంటాయి. ఇట్లా వచ్చి ఇట్లా అవుతుంది, ఒక పెద్ద బార్ మ్యాగ్నెట్ లాగా తయారైతుంటది. ఇది నార్త్, ఇది సౌత్ ఆఫ్ ది ఎర్త్. ఇది నువ్వు దీంట్లో ఏదైనా మ్యాగ్నెట్ పెట్టావు అనుకో, దట్ విల్ గో అలాంగ్ ది నార్త్ అండ్ సౌత్ డైరెక్షన్ ఉంది. అర్థమైందా? ఇస్ ఇట్ క్లియర్? ఓకేనా? చలో, The third point in రాసిన చూడండి నాన్న. The poles are situated near the ends of the magnet and not exactly at the ends. అంటే if I am taking the bar magnet like this, ఇది బార్ మ్యాగ్నెట్ అనుకోండి, ఓకేనా. సో బార్ మ్యాగ్నెట్ కి ఇది సౌత్ పోల్. I'll try to write with the other pen. ఇది ఇక్కడ ఉంటుంది ఒక పోల్, ఇది ఇక్కడ ఒక పోల్ ఉంటుంది. This will be north pole, this will be your south pole. The length of the magnet is center నుంచి ఇక్కడ వరకు ఇది L, మళ్ళా ఇక్కడ నుంచి ఇక్కడ వరకు ఇది L. అంటే టోటల్ లెంత్ బిట్వీన్ N అండ్ S విల్ బి ఈక్వల్ టు 2L. ఓకే, అండ్ ఇక్కడ నుంచి ఇక్కడ వరకు దట్ విల్ బి యువర్ జామెట్రికల్ లెంత్. ఇక్కడ నుంచి ఇక్కడ వరకు this one is known as of your geometrical length. This one is your geometrical length. Okay, and this one is your magnetic length. This one is your magnetic length. Magnetic length enta 2L. So రెండు కూడా difference ఉంటాయి కాబట్టి the poles are situated near the ends of the magnet and not exactly at the ends part of relation. And they have been told you that this geometrical length ratio, that is ratio of your magnetic length divided by your geometrical length, was found to be 0.84 approximate. Okay, that is an experimental value beta. We don't have a proof of this one in our syllabus. The ratio of your magnetic length will be equal to 0.84 times of your 0.84 times of your geometrical length part of relation. Is it clear for everyone? Is it clear? The poles are represented by letter M beta. The poles are represented by your small m, and this pole is also represented by your small m. Okay now? Sure. Next side reading run. Bar magnet. Bar magnet as magnetic dipole. As magnetic dipole. We're talking about your bar magnet as a magnetic dipole. Magnetic dipole. Okay. Now see here, beta. North pole is acting as, north pole, you take it as like plus Q charge. And south pole is acting like negative charge. Isn't it? North pole is something like positive charge and south pole is something like of your negative charge part of relation. And M ante enti ikkada, M is known as of your pole strength. Terminology beta. M is known as of your pole strength, measured in your ampere meter. Measured in ampere meter. AM. AM ante enti? Ampere meter. Ampere meter. Okay. And 2L is known as what beta? Magnetic length. 2L is your magnetic length. Magnetic length. Okay, this is a basic terminology. Beta. Magnetic dipole moment anna, or magnetic moment is always equals to. This is very important formula beta. So for the bar magnet, if I am writing the given condition, yeah.
Sir, akkada value ఎంత వచ్చింది సార్? 0.84 కాన్స్టెంట్ వాల్యూ.
అది experimental constant value nana.
Okay.
ఇది actual experimental value basically. Okay, manaku syllabus derivation లేదు దాంది. But when you go for your higher studies, you may be getting the derivation of this one. But for roughly understanding, you can remember that ratio of magnetic length by your geometrical length is equals to 0.84 times of the given condition. Now see this one beta. This one is your north pole and this one is your south pole. And here is your one pole strength and here is your one pole strength. Okay. And the distance between these two pole strength is nothing but of your, how much for me? 2L. Okay. This is known as of what beta? Magnetic length. This is known as of your magnetic length. And here we are defining a term called as of what beta? Magnetic moment. Magnetic dipole. Magnetic dipole moment. Or it is also called as of your magnetic moment. Magnetic moment. Represented by letter capital A, and it is a vector. Magnetic moment is M bar is equals to, it is the product of your pole strength. It is the product of your pole strength pole strength into magnetic length, into your magnetic length. The product of your pole strength into magnetic length is known as of your magnetic moment. So m bar is equals to your pole strength is m into this one is nothing but of your 2L, isn't it? So this is your magnetic moment formula. The first formula in the bar magnetism is m bar is equals to your m into your L, m into your L part of relation. And what is the unit of this one? Better, can anyone tell me the unit of this one? A is measured in your ampere meter, length is measured in your meter. So this one is your ampere meter square. This one is your ampere meter square part of relation. Is it clear? Direction of magnetic moment is, direction of capital M bar is from south to north, beta. From south to north. Magnetic moment direction is from where, beta? South to north part of relation. So magnetic moment is from your south to north. This is your capital M bar. Clear? So this is the first formula which you need to remember in the given condition. That is about your magnetic moment. So magnetic moment is equals to your m bar into 2L, and direction of your magnetic moment is from your south pole to your north pole. Unit is your ampere meter square. This is another name for that one is magnetic dipole moment, or also called as of your magnetic moment, also called as of your magnetic moment part of the relation. Is it clear for everyone? Is it clear for everyone? So what is a magnetic moment, beta? Magnetic moment is equals to your m into your 2L. M is known as pole strength, capital M. 2 into L is known as of your magnetic length, and it is a vector quantity. It is a vector quantity. Is it clear for everyone? Adhamayinda the definition andarki? What is a bar magnet? As a magnetic dipole moment ante magnetic dipole moment or magnetic moment is defined as the product of the pole strength and the magnetic length is called as of your magnetic moment. So m is equals to a small m into 2L. Unit is ampere meter square, and direction of your m bar is from where, beta? From south direction to your north direction. Is it clear for everyone? We'll try to do one problem. See this one, beta. We got two identical thin bar magnets. Thin bar magnets. Each of length say capital L, and pole strength small m. Pole strength small m are placed at right angles. To each other. With the north pole of one touching the south pole of the other. Find the magnetic moment. Of the system. Okay, na? See this one, beta. We got one bar magnet here like this. Ikkado bar magnet undana itla. And we are having one more bar magnet here like this. Itla. Okay, na? And terminals of this one, student. This one is the north pole of the first bar magnet, beta. This is nothing but like say this one is N1. And this one is of your south pole S1. This is another pole. So this one is your N2. And this is your another pole, that is nothing but of your S2. This is the length of the bar magnet. This is nothing but of your L. And this is also your length of the bar magnet. This is also equal to your actual magnetic length and the wallet 2 times of your L. Okay, now see the question, beta. We got two identical thin bar magnets of length L and pole strength M. Din pole strength on the right now, beta M. Din pole strength on the M. Din pole strength on the M. Din pole strength on this small m. Okay, and are placed at right angles. Student, they are kept at your right angles right now here at an angle of 90 degrees. with the north pole of the one touching the south pole of the other. Student, north pole of the one is touching the south pole of the other. Find the magnetic moment. Magnetic moment direction చెప్తారా ఎవరన్నా? Magnetic moment direction is from where to where I told you beta. చూడండి, it is from south to north. అంటే ఈ బార్ మ్యాగ్నెట్ కి మ్యాగ్నెటిక్ మూమెంట్ వచ్చేసి ఈ డైరెక్షన్ ఉంటుంది m1. దీనికి వచ్చేసి ఫ్రమ్ యువర్ సౌత్ టు నార్త్ కాబట్టి దిస్ విల్ బి కమింగ్ ఇన్ దిస్ డైరెక్షన్ లైక్ దిస్. సో దిస్ ఇస్ యువర్ m2. Both of them are vectors kabatti I am trying to write here right now. So this is your m1 in the upward direction and this one is your m2 in this direction. So this is your m2. ఈ రెండు perpendicular ఉన్నాయి కాబట్టి దీని resultant ఇక్కడెక్కడో యాక్ట్ అవుతుంది. So this will be the resultant bar magnet m, isn't it? An angle between them is how much for me? 90 degrees. So how do you calculate the m net beta? M net is equals to, both of them are vectors kabatti you can apply the parallelogram law of vector addition. So this will be equal to your, this one is m1 square plus of your m2 square plus 2 times of your m1 m2 into your cos of your 90. Cos 90 is 0 kabatti మొత్తం term 0 అయిపోయింది. So net magnetic moment ఎంత వచ్చిందన్న? M net is equals to your, M net is equals to under root of your, under root of, this one is capital M square plus this one is capital M square. That will become for me how much for me? Root 2 times of your M. So this is your answer. Okay. So root 2 times of your M part of relation. This is your root 2 times of your M. M into the magnetic moment kabatti root 2 into your capital M is nothing but small m. Length of the magnet is given as of here 2L. So answer is root 2 times of your M into your L. అర్థమైంది అందరికి?
సార్ ఒకసారి క్వశ్చన్ ఎక్స్ప్లెయిన్ చేయండి సార్.
చూడండి ఇక్కడ నాన్న, we got identical thin bar magnet. Ekkodo bar magnet, ekkodo bar magnet. North pole of the one bar magnet is attached to the south pole of the other bar magnet. So they are kept perpendicular to each other. Avuna kada? So they are kept at right angles to each other with north pole of one touching the south pole of the other. Find the magnetic moment antunnadu. Magnetic moment ante enti? Magnetic moment is m into 2l. Then direction ఏంది? From south to north. ఈ బార్ మ్యాగ్నెట్ సౌత్ టు నార్త్ కాబట్టి ఈ బార్ మ్యాగ్నెట్ యొక్క మ్యాగ్నెటిక్ మూమెంట్ పైన ఉంటుంది. ఈ హారిజాంటల్ బార్ మ్యాగ్నెట్ యొక్క మ్యాగ్నెటిక్ మూమెంట్ ఈ డైరెక్షన్ ఉంటుంది. సో ఇఫ్ ఐ యామ్ టేకింగ్ ద వెక్టార్స్ ఆఫ్ దట్ వన్, దిస్ ఇస్ m1, దిస్ ఇస్ m2. Both of them are vectors kabatti the resultant is acting like this. By using the parallelogram law of vector addition, m net is equals to under root of m1 square m2 square 2m1 m2 into cos 90. You are simplifying the answer for this. Is it clear?
ఓకే సార్.
అర్థమైందా?
ఎస్ సార్, ఎస్ సార్.
ఓకేనా? చలో నెక్స్ట్ వన్ అన్న, magnetic field. Magnetic field. Magnetic field represented by your B. Represented by B. It is a vector quantity beta. It is exactly similar to the electric field. Got a magnetic field defined as what beta? It is space around a magnet beta. It is a space around a magnet. Around a magnet or current carrying, or your current carrying conductor, because current carrying conductor kuda magnetic field create chestundi, isn't it? A space around a magnet or a current carrying conductor in which its magnetic effect can be experienced. Okay na? Magnetic effect is nothing but what, like moving charges or something like. Now see, you might have been seen that if I take a bar magnet, ఎప్పుడైనా స్కూల్లో చదివింటారు మీరు, నార్త్ అండ్ సౌత్ కనుక తీసుకుంటే ఏదైనా ఇక్కడ ఒక ఐరన్ పీస్ లాంటిది పెట్టింది అనుకో, నెయిల్ లాంటిది ఏమన్నా రైట్ నో. సో దిస్ ఐరన్ పీట్ విల్ ట్రై టు అట్రాక్ట్ దిస్ నెయిల్ కదా, అవునా కదా? సో ద స్పేస్ అరౌండ్ ద యూనిట్ పాజిటివ్ చార్జ్ up to which it can attract objects nearer to it is called as of your magnetic field. So that's what I have written here right now. The space around a magnet, in which its magnetic effect can be experienced. అంటే ఈ నెయిల్ అనేది ఒకవేళ చాలా దూరంలో ఉంది అనుకో, దీనిపైన ఎఫెక్ట్ లేదు. If I keep an iron piece nearer to the bar magnet, it will try to attract this iron piece towards it. ఎప్పటి వరకు ఇది ఎంత వరకు అయితే ఫోర్స్ ఎగ్జర్ట్ చేయగలుగుతారో ఆ రీజన్ లోపల వరకు ఇఫ్ ఐఎమ్ కీపింగ్ దిస్ ఐరన్ పీస్, ఇట్ విల్ గెట్ అట్రాక్ట్. ఇఫ్ ఐ కీప్ దిస్ ఐరన్ పీస్ వెరీ లార్జ్, విల్ ఇట్ అట్రాక్ట్? నో కదా. So that is the reason this is the space, this is the region. So up to which its effect can be felt. This region is called as of your magnetic field. Its region is called as of what? Magnetic field. And SI unit of this one is, the statement was given by your scientist called Tesla. So we are taking the SI unit of this one as of your Tesla, represented by your capital T. So SI unit of the magnetic field strength enta undana, capital T part of relation. So I hope everyone got the definition of a magnetic field. It is exactly like an electric field beta. Electric field aithe the space around a unit positive charge. Ikkadaithe the space around a magnet up to which its magnetic effect can be experienced is called as of your magnetic field, and it is a vector quantity. So SI unit is your test represented by capital T. Clear? Sure. See this one. Magnetic field strength is also known as, this is an important point, magnetic field strength. Magnetic field strength is also known as what beta? Magnetic induction. Is known as what? Magnetic induction. Magnetic induction anna, magnetic field strength anna, one and the same. Magnetic field induction, or it is also sometimes called as of your magnetic flux density. Magnetic flux density. ఈ మూడిట్ల ఏ పదం యూస్ చేసినా కూడా it means it is what? B bar. It is nothing but what? B bar. How many names we are having beta? One is magnetic field strength, another is magnetic induction, or another one is known as of your magnetic flux density. Magnetic flux density, or it is also called as magnetic field strength part of relation. Is that clear for everyone? Is that clear for everyone? Flux and induction manam Gauss law. Magnetic flux is equals to B bar dot A bar, number of magnetic lines of the forces passing through the given unit area of cross section is known as of your magnetic flux. Magnetic flux, exactly like of your electric flux. Ante B bar will be equal to how much beta? B bar is equals to your magnetic flux divided by your area. Magnetic flux divided by area. So this is known as of your flux density. This is known as of your what? Flux density part of relation. So these are the different forms in which you can write the magnetic field. Ante flux ichesadu anko, I can calculate the magnetic field. Flux divided by area will give me the magnetic field. What do you mean by flux beta? Number of magnetic lines of the forces passing through the given unit area of your cross section is called as of your magnetic flux part of relation. If I write the unit of this one beta, chudandi, magnetic flux is represented by what? 1 Tesla na? So this one is your 1 Tesla, that is capital T, is equals to, flux is measured in Weber beta, that is nothing but equal to your 1 Weber divided by area is measured in meter square. So this one is nothing but of your meter square. Okay, so 1 Tesla is equals to 1 Weber per meter square part of relation, or that is equals to 10 to the power of 4 Gauss, 10 to the power of 4 Gauss part of relation. In the conversion factors, 1 Tesla is equals to 10 to the power of 4 Gauss, or 1 Tesla is equals to 1 Weber per meter square, 1 Weber per your meter square part of relation. So Tesla is nothing but what? 1 Weber per meter square, or that is equals to 10 to the power of 4 Gauss. And 1 Tesla, 1 T is equals to 10 to the power of 4 Gauss, 10 to the power of 4 Gauss. Clear? Is it clear, beta? Is it clear?
Okay, sir.
So 1 Tesla is how much better? Magnetic field ela anukunnam. Magnetic field SI unit endi? Tesla kada. So 1 Tesla is also equal to what? 1 Tesla is equals to CGS unit la 10 to the power of 4 Gauss. That is 1 Weber per meter square. That is equals to 10 to the power of 4 Gauss part of relation. Gauss is the CGS unit of the what do you call that one? Magnetic field part of relation. Clear? So what we have got right now, beta? We have got the basic definition of a bar magnet and how would it will be acting. Whenever a bar magnet is suspended freely, the direction is always from your north to south part of relation. Then we got some properties. Then in this one, we have talked about one very important point that is called as bar magnet as of your magnetic dipole, which is also called as of your magnetic moment. Magnetic moment is represented by M. M is equals to pole strength into your magnetic field. Pole strength into your magnetic field part of relation. Magnetic field, pole strength into magnetic length. M is equals to small m into your 2L. So unit is ampere meter into meter. Kabatti it is ampere meter square. And direction of the magnetic moment is always from your south to north direction. Then we have done one problem related to that one. Then magnetic field. Magnetic field is nothing but what, beta? The space around a magnet up to which its influence can be felt is called as of your magnetic field and is represented by P bar. SI unit is Tesla. And CGS unit is 1 Tesla is equal to 10 to the power of 4 Gauss. And magnetic field is also defined as of your flux by your area, flux by your area part of relation. Is it clear? Chalo. The next one is analogy with electrostatics. Analogy with your electrostatics. And take comparison. Analogy with your electrostatics and take comparison. I can exactly compare this one right now. See, ikkada oka point తీసుకున్నాం, ikkada point. Okay. Here we are talking about Coulomb's law in electric forces or Coulomb's law in electrostatics. Coulomb's law in your electrostatics. Chapandi, what is a Coulomb's law in electrostatics, beta? Between 2 point charges Q1 and Q2 separated by a distance of your d. So what was the formula for that one, beta? Force was directly proportional to the charges and inversely proportional to the square of the distance between them. So F is equals to 1 by 4 pi epsilon naught into your Q1 into Q2 divided by your d square. Isn't it? So like charges, it will be repelling. You know that for like charges, the force is nothing but of your repelling. And for your unlike charges, it will be attracting. It will be your attracting. In the same way, if I am going for your analogy of your Coulomb's law, here also there is a one more law called as of your Coulomb's law in your magnetism. So Coulomb's law in your magnetism is in place of a charges. Now what we do is we'll try to take the pole strengths. Okay, ikkado pole strength is M1 and another pole strength is right now here M2. Okay, separated by a distance of your d between them. So here also force is directly proportional to the product of their pole strength and force is inversely proportional to the square of the distance between them. Removing the proportionality constant, we get certain constant known as of your K. This one is nothing but of your M1 into M2 divided by your d square. So this is the force between the two pole strengths of your bar magnet, where the value of the K is equals to your mu naught by your 4 pi. Value of the K is equals to how much for me? Mu naught by 4 pi part deflation. That means the formula will become for me F is equals to mu naught by 4 pi. Mu naught by your 4 pi into your, this one is your M1 into M2 divided by your d square. So the force between the two pole strength is given by the formula F is equals to mu naught by 4 pi into M1 M2 by your d square. What are M1 and M2, beta? M1 and M2 are nothing but of your pole strength. This is known as of your pole strength. Mu naught is known as of your permeability of your free space. Permeability of your free space. K అనేది ఇక్కడ ఏందన్నా 1 by 4 pi epsilon naught లా right now. We are talking about your epsilon naught is known as of what? Permittivity. గుర్తుందో లేదో? This one is known as of your permittivity. That means it will allow the electric lines of the forces, and permeability means it will allow the magnetic lines of the forces between them. So like poles will attract, repel, and unlike poles will be attracting. You can write out this one. So like poles will what? Repel. Unlike poles, beta. Unlike poles will attract. Okay, so this is the second formula which you need to remember in the magnetism, beta. Force between the two pole strength of your bar magnets M1 and M2 is directly proportional to the product of their charges, inversely proportional to the square of the distance between them. So F is equals to K into M1 M2 by d square. proportionality constant was given as mu naught by 4 pi, where mu naught is known as of your permeability of free space, and the value of the mu naught value is equals to 4 pi into 10 to the power of your -7. That is experimental value beta. I'm writing here itself. Mu naught is equals to 4 pi into 10 to the power of -7. ఓకే, ఇక్కడ ఎప్సిలాన్ నాట్ వాల్యూ ఎంత అన్న 8.8 కదా. 1/4 పై ఎప్సిలాన్ నాట్ వాల్యూ ఎంత 9 into 10 to the power of 9. అదే విధంగా మ్యూ నాట్ వాల్యూ వచ్చేసి 4 pi into your 10 to the power of your -7 part of relation. Is it clear for everyone? Is it clear for everyone? Okay na? Is it clear beta? So Coulomb's law in the magnetism is given by the formula F is equals to your mu naught by 4 pi into m1 into m2 by your d square part of a relation. Is it clear? అర్థమైందా?
అర్థమైంది సార్.
చలో ఒక ప్రాబ్లం చేద్దాం దీనిపైన. Calculate the force. Calculate the force acting between two magnets. Acting between two magnets of length d each. And pole strength small m each, when the separation between their north poles is small d. Okay, and separation between south poles is south poles is 3d. Okay, so first option is 11/18 times of k into m square divided by d square and repulsive. Second option is 11/18 into k is a constant beta, m is a pole strength, m square divided by d square, and it is your attractive. Third one is 18/11 into k into m square by d square into this one is your attractive. And fourth one is 18/11 into your km into your square divided by d square, and this will be equal to your repulsive. Okay, now read the question carefully. Calculate the force between two bar magnets. We are getting two magnets of pole strength and d. Pole strength of that one is given how much? Two magnet of length and how much for me d. And each magnet length and d. And pole strength is given as of your m. And pole strength is m. Each other, when the separation between the north pole is nothing but d. Ante ikkada oka north pole undi like this. And here there is another north pole like this. Okay, if this is a north pole m1 and this is the north pole n2 and this is your south pole s1 and this is the south pole s2, distance between them is given how much for me? You రెండిటి మధ్యల distance ఎంత d. This one is already again for me d, and this one is also already for me d. అంతే కదా? See, calculate the force between the two magnets of the length of this one is d, length of this one is d, length of the magnetic length of d each, and pole strength m each, when the separation between them ante n1 and n2 between their north poles anadu kada, between the north poles is how much for me your d, and separation between the south pole s1 and s2 mother distance and d plus d plus d, that will be equal to your 3d. అర్థమైందా క్వశ్చన్ ఎక్కడ వరకు? Is that clear? Is that clear? This is your first one. This is your first magnet and this one is your second magnet. Okay, so let us try to talk about this one. So I'm taking this one right now here. So if I'm talking about force on first one, due to second one. Due to second one. Now tell me what will be the condition? That means force exerted by your N1 and N2. ఈ రెండింటి మధ్యలో ఏం ఫోర్స్ ఉంటుంది చెప్పండి. N1 and N2 will what force?
Repulsive.
Repulsion. That means I can represent it by negative sign beta. Minus constant ని k తో represent చేసుకుంటున్నాను. M into M, this will become M square. Distance between them is nothing but D square. Force between S1 and S2 ఎంత అవుతుంది? Force between S1 and S2. S1 and S2. S1 and S2. ఈ రెండింటి మధ్యలో డిస్టెన్స్ ఎంత నాన్న? S1 and S2 మధ్యలో డిస్టెన్స్ ఎంత? That is equals to, it will be an attractive or repulsive? It will be a repulsive again. K into your M square divided by distance between them is nothing but of your 3D square. Then force between your N1 and of your S2. Force between your N1 and S2. Force between this pole and this pole. అవును కదా, ఎందుకని దీని పోల్ స్ట్రెంత్ M, దీని పోల్ స్ట్రెంత్ M, దీని పోల్ స్ట్రెంత్ M, దీని పోల్ స్ట్రెంత్ M. So N1 and S2 with the distance ఎంత అన్న? D and D. That will be equal to how much for me? 2D. Attractive or repulsive? Can anyone tell me? North pole and south pole kabatti attractive. So it is a plus K into M M square divided by distance between them is how much for me? 2D square. దాని తర్వాత force between your S1 and your N2. అంతే కదా, force between your S1 and your N2. ఈ రెండింటి మధ్యలో కూడా డిస్టెన్స్ ఎంత రైట్ నౌ? 2D. So that is also your attractive in nature. So it is a K into your M square divided by your 2 into your D whole square. వచ్చింది అందరికి? ఈ క్లారిటీ వచ్చింది అందరికి? I first calculated the force between N1 and N1. Then I calculated the force between S1 and S2. Then I calculated the force between your what do you call that one? N1 and as well as of your S2. Then I calculated the force between. Then I calculated the force between S1 and as well as of your N2. So
Sir?
అన్ని 4 పోల్స్ ఉన్నాయి కాబట్టి 4 pairs వచ్చాయి. చెప్పనా?
సార్ ఇప్పుడు ఒకవేళ 3 ఉంటే N1 N2 N2 N3 అలా 6 7 టైం అలా క్యాలిక్యులేట్ చేయాలా సార్?
3 ఎలా అయితే చెప్పరా నువ్వు నాకు?
అంటే 3 మ్యాగ్నెట్స్ అరేంజ్ చేసినప్పుడు
3 magnets అరేంజ్ చేస్తే అలా చేసుకోవచ్చు, ప్రాబ్లం లేదు.
అంటే ఎవరి పోల్స్ మధ్యలో అట్రాక్షన్ రిపల్షన్ చూసుకొని అన్ని చేయాలా సార్?
అన్ని చేసుకుంటూ పోవాలి. ఓకేనా? ఇప్పుడు చూడు, ఇది ఎఫ్ నెట్ ఎంత అవుతుంది చెప్పండి. ఎఫ్ నెట్ ఈజ్ ఈక్వల్స్ టు దీని సమ్మేషన్ కదా మొత్తం, ఇవన్నీ యాడ్ చేయాలి. అన్ని ముందు యాడ్ చేసుకుంటున్నాను నేను. దిస్ వన్ ఈస్ కే ఇంటూ యువర్ ఎం స్క్వేర్ డివైడెడ్ బై దిస్ వన్ ఈస్ నథింగ్ బట్ 4 ఇంటూ యువర్ డి ప్లస్ ఇది కూడా యాడ్ చేసుకుంటున్నాను. ప్లస్ కే ఇంటూ ఎం స్క్వేర్ డివైడెడ్ బై 4 ఇంటూ యువర్ డి స్క్వేర్ ప్లస్ దాని తర్వాత ఏముంది చూడండి, మైనస్ చూడండి, ఇది కే ఇంటూ యువర్ ఎం స్క్వేర్ డివైడెడ్ బై 3 స్క్వేర్ ఈజ్ హౌ మచ్ ఫర్ మీ బేటా? 9 square kada, isn't it? So one is nothing but of your d square, then minus this one is k into m square divided by this one is nothing but of your 9 into your d square. Which is andarki? So what I can take common in this one, k into m square by d square will be your common into this one will become for me how much? 1 by 4 plus 1 by 4. This one is minus 1 minus of 1 by 9. So if I take an LCM for this one is your k into your m square divided by your d square into, so here will be equal to your how much? So this one is 4 4 19, that LCM will be equal to how much beta? 36. And this will become for me 9 9. So this will become for me your 9. This one is of your plus 9. Then this will become for me 9 4 3 36. So it is minus of your 36 minus this one will be equal to 4. Survey the LCM. And that will become for me k into your m square divided by your d square into this will become how much for me beta? This one is 36. This one is 9 9 18. 18 minus 36.
Minus 22.
Minus
22.
This one is minus 22. So minus 22 ante minus of k into m square divided by d square into this will become how much beta? 11 by 18. Minus sign indicates what beta? Minus sign indicates repulsion. Avuna kada? Ochindi answer andarki? So what will be the answer? So it is repulsion. 11 by 18 times of k into m square divided by d square, repulsion will be the answer. Ochinda? Is that clear? This calculation beta, you can take care of this calculation part. Okay na? Clear beta? The next one. Analogy of electric field and magnetic field. And a magnetic field. And a similarity. Okay. So if I'm taking this one again, I'm writing a gap there. And if I'm talking about for electric charges, if I'm taking this charge here right now, Q, somewhere at a point E, somewhere at a point A, which is at a distance R, I need the electric field. So electric field at your A will be equal to how much beta? K into Q divided by your R square. K value enta 1/4πε0. అంటే పాజిటివ్ K ఉందనుకో, the electric field will be your away. నెగటివ్ ఉందనుకో, electric field will be towards. అంతే కదా? పాజిటివ్ అంటే it will be going away. Negative అంటే it will be coming inside. In the same way, here in this one, in the magnetic field part of relation, ఏమవుతుందంటే, in the place of charge, you take right now pole strength M. ఈ pole strength వల్ల somewhere at a point A, which is at a distance of your R. So magnetic field will be exactly similar to this one. BA is equals to K into, in the place of Q, I'll keep here M divided by distance between them R square. Here K value is how much better? Can anyone tell me? K value is equals to mu naught by your 4 pi. ఇక్కడ K value ఎంతనన్నా? K value here it is 1/4 pi into your epsilon. అంటే ఒకవేళ నార్త్ పోల్ ఉందనుకోండి, then magnetic field will be your away. If it is a south pole, then it will be your towards. Okay na? Is it clear? Is it clear? Magnetic field strength formula endanna? B is equals to your, I can write here, magnetic field strength at a point A will be equal to mu naught by 4 pi into your M by your R square, So this is the magnetic field strength formula, part of relation. So this is the formula which you need to remember. Okay na? And this is your electric field part of relation. Now north pole unte away and south pole unte towards. Clear? Is it clear?
Yes, sir.
Sure. Take one problem for this one. Like say for example, we got two like poles, two like magnetic poles, of strengths 5 ampere meter and 20 ampere meter, which are situated 1 meter apart, At what point on the line joining the two poles, will the magnetic field be zero? See the question carefully better first. We have got right now what? Two like poles. That means, like say this is your one pole strength M1 and this is your another pole strength M2. Two like north poles of strength 5 ampere and 20 ampere. Ante దీని యొక్క north pole, this one is your north pole and this one is your north pole. Like poles అన్నాడు కదా, two like poles. Pole strengths different ఉన్నాయి కదా, and are situated 1 meters apart. అంటే ఈ రెండిటి మధ్యల distance, this distance R is equals to your 1 meter. At what point on the line joining ఈ రెండిటి మధ్యల the poles will be having the magnetic field 0. So somewhere here అనుకుందాం, the magnetic field is 0. Magnetic field 0 అంటే this M2 will exert the magnetic field on this one beta. This one is your B2 and this M1 will exert the magnetic field on this one beta. This is your B1. ఇది 0 అవ్వాలంటే B1 must be equal to B2 కదా నాన్న, అవునా కదా? B1 must be equal to your B2, isn't it? If it is at a distance of your x beta, ఒకవేళ ఈ పోల్ స్ట్రెంత్ x ఉంది అనుకో ఇక్కడ నుంచి ఇక్కడ వరకు, the remaining distance ఎంత అవుతుంది? 1 minus of your x, అంతే కదా? ఈ పాయింట్ where the magnetic field is becoming 0 is x from the first bar magnet అనుకుందాం, ఫస్ట్ పోల్ స్ట్రెంత్ సారీ. సెకండ్ పోల్ నుంచి ఎంత దూరంలో ఉంటుంది అది? 1 minus of your x. దీని పోల్ స్ట్రెంత్ ఎంత ఇచ్చాడు మనకు? 5 ampere meter M1. M2 is given how much for me beta? 20 ampere meter. That is difference. That is the reason I have taken M1 and as well as a M2. So magnetic field at this point is the Q అనుకుందాం. So magnetic field at Q is equals to 0 అంటే B1 must be equal to your B2. B1 must be equal to B2. అంతేనా? ఇక్కడ వరకు అర్థమైందా? అంటే this one is K, దీని పోల్ స్ట్రెంత్ M1 divided by your x square must be equal to, this one is K, దీని పోల్ స్ట్రెంత్ వచ్చేసి M2 divided by 1 minus of your x whole square. This K is gone for me. So M1 ఎంత ఇచ్చాడు మన దగ్గర? 5 divided by your x square is equals to M2 వాల్యూ ఎంత ఇచ్చాడు? 20 divided by 1 minus of your x whole square. Now can I simplify this one beta? ఇది ఎంత అవుతుంది చూడండి. So can I do the calculation here? Yeah. So this one is 1 minus x divided by your x whole square is equals to, this will become for me 20 by 5. 5 ones are 5 fours are. అంతేనా? అంటే this will become for me 1 minus x divided by x is equals to 2. అంతే కదా? స్క్వేర్ తీసేసుకుంటున్నాను. అంటే 1 minus x is equals to ఎంత? 2x. అంటే 3x will be equal to how much? 1. అంటే x will be equal to how much for me? 1 by 3. 1 by 3 అంటే ఎంత? 0.33. That means at a distance of x is equals to 0.33 meter, the magnetic field will become 0. The magnetic field will become 0 part of relation. Is that clear for everyone? Is it clear for everyone?
Sir, once explain diagram, sir.
చూడన్నా, ఇదో పోల్ స్ట్రెంత్, ఇదో పోల్ స్ట్రెంత్ అన్న. నార్త్ పోల్, నార్త్ పోల్, 2 బార్ మ్యాగ్నెట్స్ తీసుకున్నాం, నార్త్ పోల్ అండ్ నార్త్ పోల్, అండ్ బోత్ ఆఫ్ దెమ్ ఆర్ రిపెలింగ్ బేటా. బోత్ ఆఫ్ దెమ్ ఆర్ రిపెలింగ్ టువర్డ్స్ ఈచ్ అదర్. అవును కదా? అంటే M2 is exerting the force on M1 and M1 is exerting the force on your M2. ఇప్పుడు ఈ రెండు ఫోర్స్ల మధ్యలో ఫోర్స్ ఎక్కడో somewhere magnetic field 0 అవ్వాలి. I don't know where it is becoming 0, so I'm assuming that point as Q. Somewhere at a point Q, if magnetic field is 0 అనుకుంటే, magnetic field at your Q 0 అవ్వాలంటే this B1 must be equal to B2 కదా? If these two are balancing, then the net magnetic field will become how much for me? 0. Is it clear?
Okay, sir.
ఓకేనా? ఇప్పుడు ఇది ఈ M1 నుంచి x డిస్టెన్స్ లో ఉంది అనుకుందాం. ఆ x వాల్యూ క్యాలిక్యులేషన్ ఫార్ములా యూస్ చేసి, ఒకవేళ ఈ M2 నుంచి అడిగాడు అనుకో, M2 నుంచి అడిగితే 1 minus x అంటే 1 minus 0.33 చేయి. దట్ విల్ గివ్ మీ ది ఆన్సర్. క్లియరా? ఇస్ ఇట్ క్లియర్?
Clear, sir.
ఏమైనా డౌట్ ఉంటే అడగండి ప్లీజ్, లెట్ మీ నో. నో ప్రాబ్లం. క్లియరా? చలో, ఓకే. ఒకవేళ ఇది కన్ఫ్యూజన్ ఉంటే యూ కెన్ డూ లైక్ దిస్ ఆల్సో బెటర్. యూ కెన్ కీప్ వన్ మోర్ హెడ్డింగ్, న్యూట్రల్ పాయింట్స్. న్యూట్రల్ పాయింట్ అంటే ఏంటి? 0. న్యూట్రల్ పాయింట్స్ ఇన్ కంబైన్డ్ field, in combined field due to isolated magnetic poles, due to isolated magnetic poles. So we are talking about your neutral points in your combined field due to your isolated magnetic poles. So let us try to talk about first one. I am taking like poles. If I am talking about your like poles అంటే ఇక్కడ పోల్ స్ట్రెంత్ ఉంది అనుకుందాం నాన్న, M1, and somewhere here there is another pole, that is nothing but M2. Both of them are north beta. This one is your north and this one is your north. Okay. Somewhere in between them, there is a neutral point. So this is this is your neutral point. I don't know how much it is. ఈ రెండిటి మధ్యలో ఇది x ఉందనుకో ఇక్కడ నుంచి రెండిటి మధ్యలో డిస్టెన్స్ d అనుకుందాం. డిస్టెన్స్ బిట్వీన్ యువర్ m1 and m2 is equals to your d అనుకుందాం. If neutral point from the m1 is at x and the remaining distance will become how much for me? D minus of your x. Okay. So at neutral point, at your neutral point, this will exert the force on this one beta. Chudandi. This B2 will exert the magnetic field on this one. So this one is your B2. And this B1 will exert the force on this one. This is your B1. Equal and opposite kada. Indukani, sorry, not equal. So they are in opposite direction. Indukani the M1 is the M2 kada. So this will exert the force on M2 and M2 will exert the force on your M1. So at neutral point, what is the condition? B1 must be equal to your B2. So B1 into the mu naught by 4 pi into pole strength of this one is M1 divided by your x square is equals to this one is your mu naught divided by your 4 pi into your M2 divided by this one is your d minus of your x whole square. Okay, mu naught by 4 pi, mu naught by 4 pi gets cancelled. So this one is M1 by your x square is equals to M2 by your d minus of your x whole square. Okay, now so from this one, if I simplify it, I'll get this neutral point x is equals to in the calculation will be getting x is equals to d by under root of your this one is your m2 divided by m1. This one is nothing but plus until like poles kochesi positive avutundi. Like poles kochesi positive avutundi. So that will be the direct shortcut form. So the neutral point can be calculated for the like poles. X is equals to d by under root of your m2 by m1 plus 1. M2 by m1 is nothing but what beta? This one is nothing but of your pole strengths. This one is your pole strength and d is the distance between the two pole strengths part of a relation. Clear for everyone? Ade vidhanga unlike undi anukondi. If you may ask me, sir, what happens to unlike? So if I'm talking about your unlike poles, now you need to tell me. If I'm talking about your unlike poles, ఏమవుతుందో చెప్పండి. Unlike poles ante ikkada మన దగ్గర north pole ఉంది అనుకోండి. Say for example, this one is your m1 and at a certain distance somewhere here right now, I'm having one more pole strength that is nothing but of your m2. And polarities of this one are right now different. Like say this is your north pole and this one is your south pole. This one is your south pole. And see in this one, neutral point is always lying. So we'll write here right now, neutral point ante x. This one x. Neutral point is nearer to, it is always nearer to weaker pole. It is always nearer to your weaker pole. Okay. Is it clear? Is it clear? So for like poles, neutral point neutral point is nearer to the weaker poles part of relation. Now see here, in this one m1 and as well as of your m2 part of relation, both of them are what? North and as well as of your south, isn't it? And say here m1 is lesser than of your m2. M1 is lesser than of your m2 part. Now see, distance between them is no doubt this one is nothing but of your d. M1 is lesser than kabatti, this will exert the force on this one and it is somewhere outside. Neutral point is always at your outside. This is your here. Ante, so for the given condition right now, what you assume is here you assume a unit to north pole. A unit to north pole. Because of this one, the magnetic field is in this direction. So this will be equal to B1. And because of this one, the magnetic field will be in this direction. This one is nothing but of your B2. Okay. And neutral point is always lying away and closer to the weaker poles beta. So in this one, neutral point lies, an unlike condition will lies always closer to weaker poles and outside the line joining m1 and m2. అంటే అన్లైక్ పోల్స్ లో నీకు న్యూట్రల్ పాయింట్ ఎప్పుడు కూడా నీకు బయటపడుతుంది. సో దిస్ వన్ ఈజ్ యువర్ న్యూట్రల్ పాయింట్ బెటా. దట్ న్యూట్రల్ పాయింట్ ఐఎమ్ రిప్రజెంటింగ్ బై యువర్ n. I'm representing it by your n. So at neutral point, what is again condition? B1 must be equal to your B2. So let's say this neutral point from this distance, if it is at your x. Okay now. So B1 will be equal to how much better? Can anyone tell me? B1 will be equal to your mu naught by your 4 pi into this one is m1 divided by this B1, this north pole from this pole ఎంత దూరంలో ఉంది? x దూరంలో ఉంది. అంటే that will be equal to your x square. That is equals to mu naught by your 4 pi into this one is your pole strength m2 divided by this neutral point from this south pole is it is distance of d plus x. It means this is d plus of your x whole square. Mu naught by 4 pi, mu naught by 4 pi gets cancelled. So it is m1 by your x square is equals to this one is your m2 divided by d plus of your x whole square. If I simplify this one, we will be getting the formula x is equals to this one is your d divided by under root of your m2 divided by your m1, and this one is minus. For unlike poles you take minus, and for like poles you take it as of your positive. Okay, so these are the two shortcut formulas you can remember. For like poles, the neutral point is in between and nearer to the weaker one. So x is equals to d by under root of your m2 by m1 plus 1. If it is an unlike poles, the neutral point is outside and nearer to the weaker point, and it is calculated with the formula x is equals to d by under root of your m2 minus of your m1 minus of your one part of relation. Is it clear for everyone? Is it clear? These are directly shortcuts better. You can see it in your materials. You will be having this direct shortcuts. You can learn this shortcut. For unlike poles, it is negative, and for like poles, it is your positive part. Okay, now? Sure. Next one is any analogies? This one is second analogy. Now let us try to go for third analogy. Third one is analogy of electric field, electric and magnetic fields due to an dipole, due to an electric dipole and magnetic dipole, magnetic dipole, or we also call as of what? Bar magnet, due to your bar magnet, due to a bar magnet. So we are comparing the electric field and magnetic field due to what? In electric dipole and as well as of your magnetic dipole. Electric aithe meeku already guర్తుంది కదా formula. So again, if I'm making the comparison right now, this one is your comparison. So number A, on axis of electric dipole, గుర్తుందా? We are having one negative charge and we are having one positive charge, plus q and minus q, plus q and as well as of your minus q part of relation, and this is the distance between them. There is nothing but equal to some d anukundam. So electric dipole is somewhere outside, somewhere at this point P, somewhere at this point P. So because of the positive charge, electric dipole is in this direction E1. Because of the negative, this one is in the opposite direction E2. So E net on axial portion will be equal to how much better? Formula E axial is equals to K into your 2P divided by your R cube. That is along your P. Along your P. And the point P and in the same direction basically. Where K value is equals to how much better? K value is equals to 1 by 4 pi into your epsilon naught. For the axial condition, if I am writing, this is your formula. Isn't it? In the same way, on the axis of your bar magnet, number A, on axis of bar magnet, and the bar magnet nana. This one is your bar magnet, and this one is your south pole, and this one is your north pole. Magnetic moment ekkadi nunchi ekkadi varaku annamu? Magnetic moment within the bar magnet, it is always from south pole to north pole. That is your magnetic moment. That is nothing but of your m bar. So somewhere at this point anukundam, somewhere at this point P, from this center, this is at a distance of your, this is at a distance of R. Idu kuda from this center this point is at a distance of your r. The derivation and already Jeshan, you can see it your notes is basically. So B net at this point is one because of your north pole, this is B1, and another is because of your south pole, this one is in the opposite direction, B2. Okay now, so B axial will be equal to your how much? B axial will be equal to vector kabatti B bar is equal to same. This will be K. In the place of P, you write as M. That is 2 times of your M divided by your R cube, divided by your R cube, and it is along your magnetic moment. Whatever is the direction of magnetic moment, axial is also in the same direction. K value K value here is how much for me? Mu naught by your 4 pi. That means a magnetic field due to a magnetic dipole on axial position is given by the formula mu naught by your 4 pi, mu naught by your 4 pi into 2 into your M divided by your R cube. So this is your magnetic dipole on the axial position. Okay now? Is that clear? Comparison మరి చెప్తున్నాను. So it is easy to remember. Electric field ఎలా అయితే వచ్చిందో magnetic field కూడా అదే వస్తుంది. In the place of P here, P is nothing but what? Dipole moment. Here M is known as of your magnetic dipole moment part of relation. So on axial portion of a dipole moment, the magnetic moment is B is equals to mu naught by 4 pi into 2M by your R cube part of relation. In the same way, if I'm talking about your B, number B. Number B is what? On equatorial line. On your equatorial line. చెప్పండి సార్ ఫార్ములా గుర్తుందా అందరికి? ఈక్వటోరియల్ లైన్ పైన ఫార్ములా చెప్పండి ఒకసారి. If this is a positive charge, this is your plus q and this one is your minus q. Both of them are separated by certain distance right now. Somewhere at this point, this is your equatorial point right now for me. So this is your point of your P. This is positive kabatti. So electric dipole ఎలా ఉండదు గుర్తుందా మీకు? So this is one direction right now and this is your another direction. Magnetic dipole moment is always from positive to your negative. You take this one as positive pole and this one you take it as of your negative charge. This is your minus q, this is plus q. Dipole moment is from your negative to your positive. So one electric field వచ్చేసి ఈ direction లో వస్తుంది, that is nothing but E2, and because of this one the electric field is in this direction, that is nothing but E1, and net electric field వచ్చేసి ఈ direction లో వస్తుంది. This is nothing but of your E net. గుర్తుందో లేదో మీకు? So E is always perpendicular, so E equatorial will be equal to your minus of your K into P divided by your R cube, isn't it? Minus and it is in the negative x-axis. In the same way, if I am talking about your equatorial point on your equatorial line of your bar magnet, అంటే ఇది మన బార్ మ్యాగ్నెట్ అనుకుందాం. This is your bar magnet and this is your south pole and this is your north pole. Magnetic moment ఎక్కడి నుంచి ఎక్కడి వరకు ఉంటుందన్న ఇంతకు ముందే చెప్పాను. Magnetic moment is always from south to north direction. అంటే magnetic moment from this one is in this direction. This is your capital M. On the equatorial point రావాలి కాబట్టి this equatorial position is somewhere at a distance of r. So at this point, if I'm keeping a north pole, so this is some distance. This is r, this is l, this will be under root of your l square plus r square. So దీని వల్ల magnetic dipole moment ఇదేమో ఒక డైరెక్షన్ అవుతుంది B1 and దీని వల్ల ఈ డైరెక్షన్ అవుతుంది. This is nothing but of your B2. What you assume is, we assume here to be keeping a unit north pole. ఎక్కడైతే పాయింట్ ఉంటుందన్న ఆ పాయింట్ కాడ ఎప్పుడు కూడా ఒక యూనిట్ నార్త్ పోల్ తీసేసుకుంటే డైరెక్షన్ చెప్పండి. ఈ నార్త్ కాబట్టి రిపల్షన్ అయ్యి ఈ డైరెక్షన్ పోతుంది. ఇది నార్త్ సౌత్ కాబట్టి ద డైరెక్షన్ ఇస్ టువర్డ్స్ ద సౌత్ డైరెక్షన్ ఫర్ దిస్ వన్. అంటే డైరెక్షన్ ఆఫ్ ది మ్యాగ్నెటిక్ ఫీల్డ్ ఏ డైరెక్షన్ వస్తుంది? ఈ డైరెక్షన్ వస్తుంది. అంటే దిస్ విల్ బి ఈక్వల్ టు బి నెట్. So B net will be the same formula right now. B on your equatorial position will be equal to, due to the bar magnet, it is minus of your K into your M divided by your R cube. The value of K will be equal to how much better? B equatorial will be equal to, this one is minus of your mu naught by your 4 pi into your M by your R cube. ఒకవేళ డైరెక్షన్ ఇచ్చేస్తే నెగటివ్ సైన్ రాయాల్సిన అవసరం లేదు. నెగటివ్ సైన్ ఇండికేట్స్ దట్ ఇట్ ఈస్ ఇన్ ద నెగటివ్ x-axis part of the relation. Is it clear for everyone? Okay na? చూడండి. So we got the electric dipole on the axial position, that is a 2k into p by r cube. అదే విధంగా magnetic field లో కూడా సేమ్ ఫార్ములా, just in the place of the p you replace it by your capital M. Derivation again same లాగానే ఉంటుంది, పెద్దగా ఏం తేడా ఉండదు. So b and axial position is mu naught by 4 pi into 2m by your r cube. On equatorial, it is minus of mu naught by 4 pi into m by your r cube. Okay, na? Is it clear? Chalo. And number C. Incoti. It is on your any general point. On general point. And general point. General point already చెప్పాను మీకు ఇది నెగటివ్ చార్జ్ ఇది పాజిటివ్ చార్జ్ మైనస్ క్యూ ప్లస్ క్యూ నెగటివ్ డైపోల్ సో దిస్ విల్ బి ద డిస్టెన్స్ బిట్వీన్ దెమ్ అనుకున్నాం డైపోల్ మూమెంట్ ఈస్ ఆల్వేస్ ఫ్రమ్ యువర్ నెగటివ్ టు యువర్ పాజిటివ్ పాయింట్ పి అనేది నేను సమ్ జనరల్ పాయింట్ తీసుకుంటున్నాను ఇక్కడ ఎక్కడో పాయింట్ తీసుకుంటున్నాను దట్ మీన్స్ ఇక్కడ నుంచి ఇక్కడ వరకు దిస్ వన్ ఈజ్ మేకింగ్ ఎన్ యాంగిల్ ఆఫ్ టీటా అండ్ దిస్ వన్ ఈజ్ ఎట్ డిస్టెన్స్ ఆఫ్ యువర్ ఆర్ గుర్తుందా మీకు దిస్ వన్ ఈజ్ యువర్ ఎలక్ట్రిక్ ఫీల్డ్ డ్యూ టు యువర్ ప్యారలల్ and this is your electric field due to your perpendicular. Net electric field will be somewhat like this. So this one is nothing but E net and this is making an angle of your alpha. Electric field detail ga cheppanu meeku gurtundo ledu. So what is the formula for this one right now? E net will be equal to, if I am writing in terms of magnitude, E net is equals to your K into your P divided by your R cube. This one is under root of your, this one is your 3 into your cos square theta plus of your 1. Angle ganaka raskunte tan alpha is equals to your 1 by 2 times of your tan theta. Exactly same for this one also. On general point for this one, on any point you can write otherwise. On any point P in terms of your R and in terms of your theta. So idi bar magnet anukundam. This is your bar magnet. Okay, this one is south pole beta. This one is your north pole. Okay, and pole strength is always from your south to north. So this is your magnetic moment, that is nothing but capital A. Somewhere e point kada anukundam, somewhere at that given point ante, so from here it is making an angle of theta. So here is magnetic field due to your parallel and here is magnetic field due to your equatorial perpendicular. Resultant will be like this. So this is your resultant, that is nothing but B net and it is making an angle of your alpha. So what is the formula right now for this one? Magnitude of your B net, magnitude of your B net will be equal to, this one is your K into your M divided by your R cube. K into your M divided by your R under root of your 3 into your cos square theta plus of your 1. An angle made by this one is tan alpha. Tan alpha is equals to your half into alpha into your tan theta. Okay, so just compare with the previous of your electric field and try to read it better. That will be easy for you to understand this concept right now. So this is one important formula in this one which you need to remember. Next one is nothing but on equatorial position you need to remember for this one, and next one is nothing but on axial position we need to remember for the given condition, and next one is nothing but direct shortcut formula for your unlike poles and as well as of your like poles part of relation for your like poles. Small m ante nothing but for your pole strength right now for me. So simplify it, we can do this relations. Okay na? So in study hours we will try to do the problems on this topic better. So please try to do attend the study hours part of relation because I need to do a good number of numericals. So in study hours in today's session I'll try to do some problems related to your magnetism and the given condition, and if possible I'll also teach you some topic related to the work done given conditions. Okay na? ఇది ఒకసారి చదవండి, నేను నోట్స్ పంపిస్తాను మీకు. సో యూ ట్రై టు స్టడీ దిస్ వన్ అండ్ ఇఫ్ యూ ఆర్ హ్యావింగ్ ఎనీ డౌట్స్ ఇన్ స్టడీ అవర్స్ యూ కెన్ ఆస్క్ మీ రిలేటెడ్ టు దిస్ టాపిక్. ఓకే, చలో బాయ్ బేటా. డౌట్ ఉంటే యూ కెన్ టాక్ టు మీ బేటా. సాత్విక్,
చెప్పండి.
సాత్విక్, గానేష్, ఎలక్ట్రిక్ ఫీల్డ్ ఒకసారి ఈ రోజు రివైజ్ చేయండి అన్న ఒకసారి. ఆ ఫార్ములేస్
ఓకే
యాక్సియల్ పైన ఈక్వటోరియల్ పైన ఉన్నాయి కదా, నోట్సెస్ పంపించాను కదా, అది ఒక్కసారి ఈ రోజు రివైజ్ చేసి అదే విధంగా అక్కడ పి బదులు ఇక్కడ ఏం పెట్టుకోండి, అంతే సరిపోతుంది, ఇంకేం లేదు బేసికల్ గా. అండ్ సమ్ ప్రాపర్టీస్ ఉన్నాయి నాన్న, ఆ ప్రాపర్టీస్ ఒకసారి చదవండి.
ఓకే సార్.
ఓకే, బాయ్ బేటా.